In this section, we'll be talking about vertical and horizontal shifting. And let's begin this section by looking at a vertical shift. So again, suppose we have a graph. And in this graph, we have two functions. We have this first function here. We'll call this f of x. And we have another function, this blue function over here, which is obtained by shifting f of x up by c units. And for now, we'll call our blue function g of x. To shift a graph vertically, what we need to do is we need to alter all the y values uniformly. In terms of functions, this is going to be equivalent to adding a constant to our original function. And so we can rewrite our g of x as f of x plus the correct constant, and we'll call this constant c. Let's summarize our idea as follows. Suppose that we have some constant c that's always greater than 0, and then there's two things that can occur. First, the graph of the function y is equal to f of x plus c is going to be obtained by shifting the graph of y is equal to f of x upward by c units. And by symmetry, the graph of the function y is equal to f of x minus c is going to be obtained by shifting the graph of y is equal to f of x downward by c units. Then, by symmetry, we also have the graph of the function y is equal to f of x minus c is obtained by shifting the graph of the function downward by c units. So now that we know how to transform a graph by shifting it vertically up and down, let's go ahead and move on to horizontal shifts. Horizontal shifts are going to occur in very much the same way. The only difference is the algebraic translation takes a little bit more work. But again, luckily this idea translates very well into pictures. So again, let's go ahead and draw a picture. So again, in this picture, we're going to have two functions. Let's let our red function be called f of x. And let's have a blue function. We'll call this again g of x. Geometrically, these functions are the same. The only difference is our g of x function has been shifted to the right of our f of x function. And to shift a graph horizontally, again, what we want to do is we just want to move all of the x values uniformly. So let's go ahead and draw a little bit more information. So the domain of our red function has a beginning point of A and an end point of B. And now that we declared a name for the domain of f of x, we're now able to shift our graphs algebraically. And this is going to be done by adding a constant to the x values in the domain before they're input into the function. Another way of saying this is that the function f of x on its domain a to b has the same values as the function f of x minus c on the domain a plus c and b plus c. So this little piece of algebra more or less highlights how we're going to shift our functions algebraically. So again, let's just go ahead and record this all down in a theorem. Suppose we have a non-negative constant c. Then again, there's two different ways we can shift our graph. In the first case, the graph of the function y is equal to f composed of x minus c is going to be obtained by shifting the graph of the function y is equal to f of x to the right by c units. And in the other direction, we're going to have that the graph of the function y is equal to f of x plus c is going to be obtained by shifting the graph of the function y is equal to f of x to the left by c units. So now that we know how to create horizontal and vertical shifts, let's go ahead and look at a few different examples. So example number one, let me just go ahead and read it out and then I'll write it down. We're going to go ahead and sketch the graph by starting with the graph of a standard function and then applying transformations. Okay, and now that we have that written down, the function that we're going to be looking at is the following. Y is going to be equal to the square root of x plus 4 minus 3. Before we get into the solution of this problem, let me go ahead and just make some notation real fast. And we're going to continue using this notation throughout, and it's just the following idea. Whenever we apply a transformation to some function f of x, we'll also call the new function f of x. And this is just going to be used to simplify what we're writing down. So let's go ahead and find the standard function. And the way we're going to do that is we're going to take the function that we're given and just peel off the transformations. So we start off with y is equal to the square root of x plus 4 minus 3. And we peel off a transformation. So in this case, let's just get rid of the negative 3. So this is going to be y is equal to the square root of x plus 4. Again, let's peel off another transformation. This time we'll peel off the horizontal shift, and so we'll get rid of the plus 4 from our function, and what we're left with is y is equal to the square root of x here. So now that we have all our transformations laid out in front of us, we can start with the function at the bottom 1, apply our horizontal shift in 2, and then apply our vertical shift in 3. So let's just go ahead and draw each of these steps out real fast. Number 1, we're just looking at the graph of the square root of x. And that graph looks something like this. And number 2, again, we're looking at the graph of the square root of x, but this time it's been shifted to the left by 4 units. And then finally, in number 3, we apply our vertical shift to our last function. And so we're going to take our last function and just translate it down by negative 3 units. So we'll get our function that looks something like this. And just to summarize, this function from our original function has been shifted down by 3 units and over to the left by 4 units. All right, so let's look at another example. Let's go ahead and write an equation for the following graph. So I'll go ahead and just write this out. So this is the graph that we're working with, but we want to transform this in 2 ways. Number 1, we're going to shift up by 2 units. and then we're also going to shift to the right by 3 units. So we can again did what we did in the last problem and just apply our transformations step by step. So in the first step, we're just starting off with our original function f of x, which is going to be equal again to the absolute value of x. And then let's go ahead and apply the shift up by 2 units. And so by applying our shift up by 2 units, our function is going to be rewritten as the absolute value of x plus 2 here. And in the last step, we can just go ahead and apply the last transformation, and we just want to go ahead and shift this to the right by 3 units. Which means that our function f of x is going to be rewritten as the absolute value of x minus 3 plus 2.